So the next topic is unit conversions. We've done many of those. It's important to know that you don't need to memorize any of them. They will be provided within the problems. So therefore, know how to solve conversion factors. If you have solved these previous problems, then you'll do just fine in the unit conversions. Most people find them a little easier. There will be some density problems. So what you need to know is what density stands for. Particularly, you need to know that density is measured in grams per mil. You also need to know that 1 mil equals 1 cc, in case you see that in the ACS exam. So all I have to do is, this is a formula problem. It can be used as a conversion factor, treated as a formula problem, meaning that a problem will give you everything but one value. So you just have to go and inventory it, saying density, grams, if you have both density and grams. And this will be your x, and you have to solve for x. Let's look at some of those problems. The conditions of the problem say that a known metal has a mass of such and a volume of such. And we need to calculate the density. Well, we know that density is gram per mil. Centimeter cubed, cc cubed is a mil. And so the answer will be 35.4 divided by 3.11. And you have to calculate that out. So we are on problem 17 now. And we asked, let's look at part B. We are asked to find a volume in milliliters of so many grams of acetone. We are given its density. So we know that density is equal to grams per mil. We have this value. We have the grams. This is my x. Therefore, what I have to do, I have to say 0.7857 equals 5.70 divided by x. And then you solve for x in your calculator, or you say that x is equal to 5.70 divided by 0.7857, and you calculate this out. Units are milliliters. Now on to chapter 3 that dealt with chemical and physical properties and transformations. Just keep in mind that for the most part, if it's not a physical transformation, it's going to be chemical transformation. This topic is tied to the topic of classification by state of matter. For example, if it's a change between two states of matter, like solid and liquid, then it's a physical change. Chemical changes involve breaking and formation of the bonds and an actual change in substance, and that is best understood by understanding what a compound is and such. We had two charts on that in chapter 3. So let's take a look at this few problems. I'll just randomly click right here. So in this case, on problem 20, we have a property such as a flammable. Well, for something to be flammable, you have to have a chemical transformation, and so therefore it is a chemical property. For for something to be odorless, odor is evaporation of a substance, therefore it should be a physical property. Color is also a physical property, therefore if something's colorless, that must be a physical property. So physical, physical, chemical. Okay, it's hiding from me. Chemical. Let's see what the next problem says. Same story. Now we're looking at a change, a transformation. So in this case, we're on problem 20, part A. A balloon filled with hydrogen gas explodes when there's a spark. Well, this is not a state of matter transition, therefore we'll have to say it's a chemical change. You're looking for propane in a barbecue evaporates away because they usually left the valve open. So that's evaporation. You cue that this is a physical transition. So in this next part C, the liquid propane in a barbecue ignites upon contact with a spark. It's not a transition involving changes in state of matter of the same substance. You actually have a change in the chemical, therefore it's a chemical transformation. So we have chemical, physical, chemical. Chemical, physical, chemical. Same story. Let's solve this problem. Several pieces, so it's problem number 25, several pieces of graphite from a mechanical pencil are broken into tiny pieces. So they're broken, we don't have transformation of a chemical, therefore it's a physical change in part A. Then the pile of graphite is ignited with a hot flame. Burning anything is a chemical change. So it's physical and chemical. And of course, you need to remember the definition of exothermic, endothermic reactions. That's classifying reactions by heat. Exothermic means that heat exits the system. Endothermic means that heat enters the system. So in this case, we have to determine whether heat is exiting or entering the system. So what is the system? It's my reaction vessel. It's my flask where I'm running the reaction. A common type, so it's problem 26. A common type of hand warmer contains iron powder that reacts with oxygen to form an oxide of iron. As soon as the hand warmer is exposed to air, the reaction begins and the heat is emitted. So pretty much our hand warmer looks like this, is emitting heat. Our system is losing heat, therefore heat exits my hand warmer. It's an exothermic reaction. So that summarizes this section. So what we just looked at was Chapter 3, Exo and Endothermic Processes. We solved this problem, and all of them should be pretty much the same. The next part is you need to know the conversion formulas. So make sure to memorize your conversion formulas between Celsius and Fahrenheit and solve these problems right here. It's just plug and chug. The hardest part is memorizing the formula.